Hey everyone, welcome back to the channel. So a recent video I posted about the Hill HX50 generated a ton of comments, a lot of controversy, a lot of agreement. So first thing, thank you to everyone who commented and said something underneath that video. I thought there was a ton of really interesting dialogue that happened, and I want Hill to succeed. I said that in the first video, and I'll say that again now. I want Hill to succeed. If their product comes to market, fantastic product. It will absolutely revolutionize the helicopter industry, but I still have a ton of concerns. So what we're gonna do in this video is I went through all the comments and I essentially summarized the top 10 thoughts that I saw, the reoccurring comments. So these are like the most controversial points and the ones that people disagreed with me the most, and I've summarized them into 10 general comments, and I'm going to put those up on screen, and I'm going to respond to those in just the way that I currently see it. And then as you guys respond in the comments, you can respond to comment or point 1, point 2, point 3, whatever point you want, and we can keep the conversation going. So I want Hill to succeed, but I definitely have some concerns like I've laid out. So let's get into it. Number 1, vertical integration. Many comments criticize my skepticism about Hill manufacturing everything in-house. The argument is that by building their own components, Hill can dramatically reduce the cost compared to traditional manufacturers who mark up parts at every stage of the supply chain. Some people pointed out that eventually a bearing manufactured by Hill will cost some crazy small number, like 1/30th of what it would cost through the traditional aviation supply chain, and this approach allows them to iterate designs much faster. So in one of the original videos I posted about this, talking about vertical integration, I absolutely understand it. I'm not an engineer, I'm not a design engineer or manufacturing process engineer, but it does absolutely make sense. To do everything in-house absolutely allows you to move faster, make the parts quicker, and then lower the price because you are doing everything in-house. I absolutely understand and agree with that. But the point about aviation on why this is a little bit different than like a car company like Tesla or Koenigsegg, I saw that name a lot in the comments. If you manufacture every single part in-house, you have to be an expert at manufacturing and an expert designer at every single aspect. Up into the bearing, you have to have that bearing perfectly engineered, perfectly balanced. That's for a bearing. Every single part of the helicopter, the transmission, the rotor system, the engine, the avionics, the upholstery, the landing gear, every single part of the helicopter, you have to be an expert if you're going to manufacture every single part. If you take something off the shelf like a bearing, yes, it is more expensive because every part of that process there is a middleman who is adding on their little profit, and then that final bearing is much more expensive. But at the end of the day, that bearing is perfect. It is exactly weighted, it is exactly tested, it is absolutely perfect. Yes, it's more expensive, but it works and it's perfect. If you were having to do every single part in-house, you have to be an expert and you have to do R&D for every single part. The amount of R&D that it would take, research and development that it would take to develop a bearing, it would take so long. I mean, maybe a bearing is not like the best example. You can probably do a bearing relatively quick, but every single part, like every off-the-shelf part, you're going to have to do research and development and multiple iterations, multiple versions of research, developing all these different iterations to just get to one point, and then you do have it in-house, and then you actually have to start manufacturing it. So you're a research and develop company, and then a manufacturing company, and then you're trying to put it all into a helicopter, and you're trying to do that for every single part. Yes, vertical integration is smart and vertical integration works, but for a very complex helicopter with so many moving parts, so many different designs, so many things that have to be aerospace grade, to try to do everything in-house is extremely hard. Very tall order. I'm not saying it can't be done, and hard things can definitely get done, but like I said, there is a reason why most companies don't do this. People said that most companies don't want to do that just because the bureaucracy and they don't want to go through it. Maybe that is true, and that they're just lazy and they'd rather just buy things off the shelf, but there is a huge cost in research and development. All right, number 2, engine development. Many viewers strongly disagreed with my take on the GT50 engine development. They argue that modern engineering tools and manufacturing methods make engine development much faster than it was decades ago. Several comments pointed out that the GT50 is based on proven designs and that the Hill team includes engineers with experience from companies like Rolls-Royce who know what they're doing. So I actually really appreciate that point about the GT50 engine. Yeah, turbine engines are relatively simple. I'm not an engineer and I can explain how one works, but I mean, maybe they are relatively simple, but they're still like super complex. I mean, it's not like the most complex engine design, but a turbine engine is still kind of a challenge to develop. But even so, let's say that they get the design developed and then you got to start prototyping it. And as you're going through the prototype, there's definitely going to be changes, even with like an engine that is very sound, very simple, very easy. Once you prototype it and then you start doing engine runs, you're probably going to have to change something. I can't imagine that they just design a perfect engine and then when they prototype it just works perfectly. So then you're gonna have to go back and redesign it and then you're gonna have to prototype again, and maybe that works perfectly on the second time, but probably not. You're probably gonna have to do a couple iterations of this research and development and prototype and developing and going back and forth through this process. So that's a very expensive process, just that. And then testing. You have to go and test this engine for many hours under very high temperature, high heat, multiple different testing configurations. I don't even know like the full length of it. It's a lot of testing that you have to go through. So then there's testing, and then there's manufacturing it. Then there's like actually producing it and manufacturing it to aerospace quality. This is just very complex and very expensive. Granted that they have a lot of money under their belt. They have a lot of money in the coffers, so they can burn through a lot of money. Even just on this engine, are they going to be able to get through the research and design and development, prototyping, all of that, then go through testing and still have money in the bank? The engine program itself might cause them to run out of money. And for example, when Honda came out with the Honda Jet, they partnered with GE, who is an engine manufacturer, and Honda is like a huge car manufacturer company. They have tons of assets and resources under their belt, and they have tons of engineers and decades of experience, and they still partnered with an engine manufacturer. I get why Hill claims to be trying to do it by themselves, but once again, extremely tall task. And what you're going to see throughout this video is all 10 of these, like, you can make a work and you can make a workaround. And this is what we talk about in like aviation and accidents. If there's like an obstacle you're trying to get around, okay, we can get around that obstacle for point 1. Point 2, okay, there's another obstacle. We can get around that obstacle. Okay. Point 3, there's an obstacle. Okay, we can get around through that obstacle this way. Point 4, we can get around. You see, all of these obstacles, you can kind of work your way around, but like an accident, like an air chain, so many things on a chain or so many different workarounds to try to find this can lead to problems. And I'm just saying that all of these workarounds and all of these chains, like, yes, there are explanations to every single answer. And on the videos, I'll bring this up a little bit later on, they have explanations for every single thing. But in like this example for the company, all of these different workarounds and all these things you're trying to tether together could potentially lead to the company and the helicopter not coming to market. Number 3, owner-built process. I received significant pushback about my understanding of the 51% owner-built requirement. Many comments explain that the owners aren't actually building the critical components themselves, but participating in a supervised assembly process with experts signing off on every step. A lot of people suggested that this is simply a regulatory strategy to expedite getting aircraft to market while certification continues. So I really appreciate this clarification. Yeah, I mean, having owners with not a ton of experience actually building the helicopter, like, that does red flags. Like, that is kind of probably not the best idea. But let's say Hill actually manufactures all the parts, they have all the parts, and then you as the owner are going to go to the factory and you are going to work on putting this helicopter together under very close supervision, under Hill's guidance and leadership. You are going to put this helicopter together. That makes more sense than how I originally presented it. But still, for a company that claims to want to revolutionize the helicopter industry, even though that this is technically just a shortcut to certification, it kind of disregards the spirit of experimental, because you are just using this as a path to proper certification because you don't have the financial coffers or the ability to go straight to certification like other companies. You're going to use this experimental carve out, which technically works. back on the way, it's like, it kind of works, but it just seems a little bit off. Critique 4, performance claims. Several commenters with aviation engineering backgrounds criticized my doubts about Hill's performance claims. They pointed out that the aerodynamic design is much more efficient than current models, with very clean and elegant and engineered designs, a streamlined rotor head, and retractable landing gear. Some noted that achieving 140 knots with that power to weight ratio isn't unreasonable given the advances in their design. Totally potentially true. I mean, I am not an engineer, and my understanding of aerodynamics is limited to the pilot understanding, the pilot flying the helicopter. I do not understand like really like the in-depth engineering levels of it. But if you look at what else is on the market in comparison, it does seem like a stretch to be able to do 140 knots with the power plant that they are talking about. It's definitely one thing to have a computer simulation, which granted are extremely good nowadays, especially in 2025 with AI and all the systems we have, all the software technology we have. I imagine you can get pretty close. But just from my experience, from what I have flown and what I have seen, and like comparing numbers, some of the performance claims are like really kind of out there. I also think that a lot of times before a helicopter is manufactured, there are really strong claims, and then when the helicopter is actually manufactured, it does not really come to pass, and I think that potentially could happen here. And this isn't even the strongest point. I mean, let's say like the cruising speed, they're claiming 140. Okay, let's say it's 130. You're still within the ballpark of everything else. Even if you're like 125 as a cruise speed, that's still within the ballpark of all the other helicopters of this category and class. The purpose of me bringing up this point is you are claiming a very high, lofty goal. If you were claiming like 120, 130, okay, but like a 140 cruise, consistent cruise is like a pretty lofty goal, so it warrants some skepticism. Critique 5, timeline concerns. While some of you definitely agreed with me about the timeline concerns, many criticized me for making this the major point. They argued that Hill has been transparent about delays and that aviation projects always take longer than expected. Some commenters pointed out that despite timeline slips, the substantial progress shown in their updates demonstrates they're moving forward steadily. Okay, potentially granted, they do post a ton of content, and I would absolutely take that over a company that's not doing that. I mean, I really appreciate the transparency. Like, transparency with everything is always better than hiding stuff and not talking about stuff. So I appreciate that they're coming out and showing stuff and talking about stuff. In their videos, they talk a lot, and Jason Hill says a lot of really good things, but the actual progress, in my opinion, and maybe this isn't like concrete fact, just how I feel, it feels like the progress isn't like quite there. Like the building, Production Center 1 is beautiful. It doesn't strike me as like all the way there, ready to start manufacturing yet. Maybe you're ready to start like R&D, like maybe you're ready to start researching some stuff and like testing some stuff, but manufacturing, Production Center 1 does not really strike me as like ready to go, but that's just my opinion. But back to the main point about delays. Yes, in aviation, delays are just like, that's the thing. That's the thing. Like, every single project gets delayed. I mean, if you go check out this video I posted about the AW09, that process has been delayed. The Bell 525, delayed. Just such a long delay process. And yes, they're going to go the experimental route, so the certification could cause things to not be delayed. But even still, I mean, the engine and the flight test, if I am understanding it correctly, they are going to do the engine ground run next month in June of 2025. And I believe their website still says they're going to do a flight test at the end of this year. Based off the videos we've seen, I think the most recent video that I've seen is like they were talking about the starter generator. Great, good, important. But man, you're talking about a full engine run? I could be misunderstanding this, but if they're talking about a full engine run next month, no, I do not see that happening. A full engine run even by the end of 2025 seems like a stretch to me. Maybe 2026 for an engine run. You're talking about a full flight test by 2025? Like, it is May of 2025. How are you still claiming this? I mean, I don't see in this world, how by the end of 2025, December of 2025, you're going to do a flight test. It's okay. I mean, you can still do delays, but what they are promising is a great product at this price point in this time frame. Yes, they have a ton of money on hand, and hopefully they have enough money and runway now, but like as timelines keep slipping, people are going to stop putting deposits in, and your additional cash flow is going to slow down. Maybe some owners will continue to inject cash, and maybe they can get cash from other sources, but like the main source that I understand that they're getting cash from is from these deposits. If these delays keep happening, then your cash income starts to slow down as your R&D is increasing more and more, and as your manufacturing process is requiring more and more cash. So it's like, as you need more money, as you're ramping this up, if delays keep happening, less income is coming in. So it's just a very hard process. 6, team experience. Many commenters felt I dismissed the credentials and capabilities of the Hill team. They pointed out that the project has been in development for over 10 years, not just recently, and that the team includes experienced professionals from across the helicopter industry. Several people noted that Jason Hill and his engineers previously worked at major aerospace companies and bring decades of collective experience to the project. So that's absolutely true, and I want to apologize if I didn't give Jason Hill and his team enough credit. From everything I can see, they do have a ton of experience, and that is good. That is not the same as having hundreds of engineers and lots of institutional knowledge behind them. Even with hundreds of engineers, processes like building a new aircraft take a ton of time. You have to have engineers with experience for every single aspect. So aerodynamic engineers, engine engineers, engineers for every aspect of the helicopter. Then you also have to have engineers for the manufacturing process. I didn't know about this, but this is actually like a job. Manufacturing system engineers, like how to go through the manufacturing process. And then you have to have like testing engineers who know how to test these systems. And then you have to have people that know how to write documentation and all of these different positions. It's extremely immense. And yes, there's artificial intelligence now that can help, and some of these positions can be eliminated, but still you need a ton of people. And I talked about this in a live stream I did talking about the Hill HX50, but still I have it pulled up on my home screen right now. Or on my computer screen, if you go onto the Hill website right now, there are not any specific jobs that Hill is hiring for. There is, under open positions, there's just like a general expression of interest with a closing date of the 28th of October, 2036, 11 years from now. On their website, they are literally not hiring for any other positions. I mean, to put it mildly, that's a red flag. If you are going through this process, I mean, are you saying that you have everyone on staff already? Companies that are growing and expanding and going from startup into actually manufacturing, you are constantly hiring for people. I mean, you legit just need hands, and you need people to do stuff, let alone like very high skilled engineers. And to not be hiring for these individual positions is very interesting and weird and concerning to me. It is a very tall task to design, prototype, engineer, manufacture all of these systems, and you need a lot of people. I'm not saying it's like complex, and I'm not saying they're going to the moon. Like, building a helicopter is not like the hardest thing in the world, but it is extremely hard, and it takes a lot of engineering and a lot of people and a lot of work, and this requires a ton of people, and it's very hard. Just the way that I presented this and the way that I see this, we'll keep going, but the way I see it is like, there are all of these things that are like just immense challenges, like very large challenges, and that's okay. People can overcome very large challenges, but when you start stacking very large projects on top of each other, it's like, can you actually build this? Like, or a chain, you're just like putting all these links together that are like huge and very strong and very brittle, and if one part falls, then the whole project falls apart. And it's like, everyone is so positive and optimistic about this, and I think it's great, but like, come on, man, we are talking about like very, very complex things, and there are some red flags that make it hard to just be totally optimistic. All right, point number 8, disruptor comparisons. Many viewers compared Hill to SpaceX, Tesla, and other companies that succeeded despite industry skepticism. They argued that established helicopter manufacturers have been complacent and inefficient, creating opportunity for disruption. Some people pointed out that if I applied my same skepticism to SpaceX in 2008, I would have been proven completely wrong. Super fair. I am 100% like skeptical. I am one of the largest skeptics on YouTube about this project. I definitely am coming out on the skeptical side of this, but let's talk about SpaceX and Tesla. SpaceX is launching rockets, which is pretty hard, but they started out with cargo and no human lives. With Hill, you are going to go put people on this immediately, and lives are going to be lost if they don't do it correctly immediately. SpaceX, when you just launch cargo into space, and if things go wrong, it can blow up in space with no one on it, or it can fall into the ocean. That is not the same as a piloted aircraft that you are going to go put families in. And then with Tesla, I mean, man, don't get me wrong, like the manufacturing process of Tesla the manufacturing is really like the beauty of it. I mean, Teslas are cool, but like a battery pack, relatively simple. This is coming from me. I'm not an engineer, but I mean, a battery pack, relatively simple. And then electric motors, like very simple. To do this on this scale is hard. And then like to put it into the fuselage and like the full self-driving, don't get me wrong, those are hard things. But like a Tesla car is like a very simple car, and that's what people love about that. Like the maintenance on a Tesla, very simple. Electric motors, very simple. Wheels, very simple. Battery packs, very simple. And if it fails, or if something doesn't work, you're on the road. You're talking about 2D, not 3D. If something fails up there in the sky, if a rotor blade delaminates, if a bolt comes out, if a part is not manufactured to the right strength, you fall and you die. If you're in a Tesla and something happens, I mean, you could die, but you're also on the road, so you can like pull over to the side or just stop and get out of your car and walk out. So Tesla and SpaceX, yes, very hard challenges. Yes, market disruptors, but way different. You're talking about cargo and going into the sky, it can explode and fall into the ocean. Or Tesla, very simple systems. I mean, hard manufacturing process, but relatively simple systems. And if it fails, you can pull over to the side of the road. With a helicopter, if a blade or a bolt or anything goes wrong, you fall and die and you kill people. It's just much different. Even still with that, I mean, hard things have been done and you can develop a hard project. I'm just saying, once again, air chain and stacking things on top of each other to eventually get to an outcome. It's like, how many different routes do we have to take? I'm not saying it can't be done, but come on. Someone's got to be a little bit skeptical, and it happens to be me. All right, critique number 9, the deposit model. Several commenters defended Hill's deposit model, arguing that it's a legitimate way to fund development. They pointed out that many of the over 1,000 deposit holders are sophisticated buyers who understand the risks. Some suggested that deposits are an investment in disrupting the industry and that customers are willing to take this calculated risk. So 100% true. I mean, if you are putting a deposit down on a Hill HX50, you are well aware that this is a non-refundable risk and that there's a chance you're not going to get your money back. So I'm not saying that people are going into this without that understanding. They definitely understand that. The reason why I brought this up is it just strikes me as a little bit of an odd funding model. Like in a startup or like some small product, okay, maybe that's one thing. For a helicopter, it just strikes me as an interesting funding model. When you look at companies like the eVTOL companies, the companies that are developing electric vertical and takeoff aircraft, those companies, in my understanding, are funded typically through like proper investment channels, like large multi-million and multi-billion dollar investments that bring those companies up. You don't have individual investors. And maybe that's a good thing, maybe that's a bad thing. And maybe it's good that Hill is trying to disrupt that by not having these large multi-billion dollar investors fund them, and maybe they're just trying to have individual people do it. But the tough thing about this structure and this model is when you have customers that are really, really excited for your product, the customers constantly want development. They constantly want pressure. If you have like some billionaire investor like far off, they kind of understand that this process is going to take a while and they have a long time horizon for the return on investment to happen. But if you have just private investors, people that just have money and they want a helicopter, they constantly want to know, they constantly want to know, they constantly want to know, and they want to see progress. Come on, progress. So you said 2027, you said we're going to have the engine run, and then you said we're going to have the first flight test, and there's constant pressure and pressure and pressure. And maybe that's a good thing, but could that potentially lead to a company cutting corners to show development, show progress, just to keep their investors that are just regular people happy? I don't know. Kind of an interesting business model. It's definitely easy to get funding at the start when there's a lot of excitement. And back when I posted my first video about the Hill HX50 at Heli Expo, when I think that was the first year that it came to Heli Expo, tons of excitement, tons of deposits. Like, yes, everyone's so excited, like they rally behind it. But as the process goes and as setbacks happen and delays happen, which are true and inevitable, and every company does that, every company has delays, the excitement and the hope starts to dwindle and the concern starts to grow, which causes deposits to slow down, like I explained earlier. So at the start, you get a ton of money. But then as research and development and prototyping continue to develop, and the delays happen, because that's typically when they happen, deposits start to slow down right when you need that injection of cash. And maybe they can get some, but it is just a very intense and challenging business model from my experience. No, someone left a comment today as I was doing research for this. I do not have an MBA. I do not have a business degree. I am also not an engineer. I didn't even go to college. I went from high school to flight school. So it is really interesting for me to come out here and speak my mind and talk about this company doing it. But I hope that in this video you'll see that I'm presenting the most logical arguments that I can see, and hopefully you can see that I'm coming from like a good rational place. I'm trying to be honest and trying to be fair. Well, let's finish with the last one. Number 10, insurance and financing. Many supporters criticized my concerns about insurance and other ownership practicalities. They pointed out that Hill plans to offer their own insurance program similar to Tesla Insurance and financing solutions. Some argued that by controlling these aspects, Hill can further reduce the total cost of ownership in ways traditional manufacturers cannot. Okay, definitely a real thing. I think Tesla does this. I'm not exactly sure. I'm not like super looped in, but okay, you're going to provide your own insurance. Great. I'm glad you have a solution for that. You're going to provide your own financing. Great. I'm glad you have a solution and financing for that. At what point do you turn into an insurance company, and what point do you turn into a bank? I'm not saying that companies can't do this, but all of the things we're trying to do, we're trying to design this helicopter, brand new helicopter. We're trying to design this brand new engine. We're trying to design retractable landing gear, the avionics, I mean, the helicopter itself, very complex helicopter. So we're trying to design all that. Then we're going to try to prototype all this. We're going to try to prototype every single thing. And then we're going to go back and we're going to test everything. And then when some things inevitably break on testing, because that's normal and that's okay, we're going to have to go back to designing something. And then we're going to have to prototype that new thing. And then we're going to have to test it again. Oh, and then the second time, everything didn't work perfectly. All right, so we got to go back again. But we have to manufacture the helicopter. Okay, but we're not just manufacturing a helicopter, which is extremely complex. We're manufacturing every single part to this helicopter. All of the bearings, all of the interior, all of the exterior, every single aspect of this helicopter, we're manufacturing. And then we're not just manufacturing it and then building the helicopter and selling it. We're going to manufacture, and we're going to have people come in, and we're going to teach our owners, we're going to teach the people who buy these helicopters how to put it together. So we're going to have a school, and we're going to teach all of them. And then once they have these helicopters out for a while, and then we're going to start to go through certification. But also, during this time, we are going to provide the financing for it. So we're going to be able to buy all of the material to manufacture and produce our helicopters, and have enough financing and money in the bank to allow financing for our customers. But not only financing, can they finance it through us, but we're also going to provide the insurance. And then if a couple of these people crash and die and their families sue and they pull from the insurance fund, we're going to be able to handle that. So you're going to handle all of the extremely complex designing, all the extremely complex manufacturing, engineering, testing, research and development, prototyping, all of that, plus teaching people how to put these helicopters together and oversight of that, and then go through certification. And then we're going to do insurance, and someone's going to crash one of these helicopters, and when they sue and their families sue, and if people on the ground die, what happens there? And we're going to do financing. Man, I hate to be a negative Nancy, but like, come on. So I'll wrap up this video because it's already getting pretty long. I want them to succeed, and I feel like I am stepping out on a ledge here, but I know some people agree with me, and I have tried to take all these comments in good faith, because I could be wrong, and I say that all the time, and it's true. Like, I want to be humble, I want to be honest and transparent, and I could be wrong. I'm not an engineer. I did not go to college. I am just a pilot, so I definitely could be wrong. But I mean, with any logical sense, hopefully you'll see that the points that I've laid out, I mean, there's a lot here. There is a lot to this air chain, and we talk about this, I'll just explain it one more time, but we talk about this like in piloting and pilot decision making. It's like, can we do something? There's this obstacle in our way. Okay, maybe it's bad weather. Well, we can kind of skirt around it. Okay, it's late at night and I'm kind of tired. Okay, but like it's a short flight. Oh, and I've got this event tomorrow, but it's all right. I just want to get home. And there's all of these things that we can kind of make a workaround and we can kind of figure it out, but then all together, all of these different workarounds cause a problem. I want them to succeed because we do need like some industry disruption, and and helicopters need to be more affordable. I agree with that because I'm like a huge advocate of helicopters and aviation. I love this. This is my day job. It is my passion. I like to talk about it on my days off. So I agree, and I want helicopter disruptions. And if Hill could do this, I would even buy a Hill helicopter because it's affordable and it's beautiful. Like, I want this to happen. But man, you are doing everything. Like everything. Like, you can't do everything. What's that quote? You can be a jack of all and a master of none. So you can kind of do every single piece, but are you going to master everything? Like, if you want to be really good at engineering engines, okay, that is your one thing. If you want to build really good helicopters, okay, you focus on the design of the helicopter, but like you substitute in this engine. Or if you want like really nice interiors or avionics, okay, you're going to do that, but you're going to find like off the shelf avionics and engine. Or if you want to be an insurance company, or you want to be a finance, but if you try to be an insurance company, a bank, a manufacturing company, a research and design company, all of these things, it's a lot to put in. I'm not saying it can't be done, but like, man, if they do this, they will absolutely be like the biggest industry disruptors. They're going to be like the biggest game in town. But if I was a betting man, the bet, in my opinion, would 100% be on this not happening. And in aviation, we want to take the bets that are likely to win. We want to lower our risk potential. Even though I want them to succeed, the likelihood that they succeed is less likely than the likelihood that they make it, as I currently see it. So enough of me rambling, long enough video. Let me know your thoughts. What do you think? Please engage with me in the comments. If you want to bring up point by point, use the points that I listed, like point 1, point 2, and let's engage with those in the comments. I love reading the comments. Let me know where I'm wrong, because even though I tried to clarify in this, I'm still probably wrong on some aspects. So let me know, and I will see you in the next one. Take care. Oh, also, if you want to set up a phone call with me, if you want to talk just helicopters, I've had many people book a phone call with me, and I really enjoy those calls. I love those conversations. If you have any questions about the helicopter industry, if you just want to chat, feel free. Link is in the description below, and I will see you on the next one. Take care.